Okay, so it is about 8:17. So I think we can get started here now. Let's make sure everything's good. Okay, good. Yeah. So, hi. This is our first time meeting in person. This is uh, Intermediate Rigging, and I am Josiah Cabral, and I will be your TA for this semester. And uh, today we're going to be talking about constraints. So, does anyone know what constraints are before we begin? Yeah, loosely. Okay, that's good because this is going to cover pretty much all the ones you'll be using in Blender. Uh, we're going to have a look at them, play with them a little bit. So it's going to be for anyone who's starting out or anyone who is more experienced. Before we get started, I want to remind you that there will be 3 lab assignments in the near future and this is all the kind of work I'll be giving you that I will be sort of creating the assignments and then assigning. So there are three each worth 5%. There are larger labs throughout the semester. Uh, right now, I'm thinking week 5, 8, and 11. I'll have these rigging challenges that I'll provide, and I'll give you like an object or a creature or some sort of part of a body, and you'll have to figure out how it moves and try to rig it. The marks will come from deformations, complexity, and the ease of use for animation. More info on that soon. But these should span throughout a whole week, so you'll get them assigned in the class, and then maybe Monday or Tuesday night I'll have them due, so you have the time to complete that. And yeah, I will post the first one like about a week before we start it, so you can see the details and everything. So, fun fact of the day or fun thing of the day, I found this video really interesting. I'm going to show you all this video from Toy Story, and it's the way they were modeling and rigging back in 1995. I thought this was really cool and a good way to showcase how much easier we have it now compared to back then. So here we go.
Basically, I get a model packet from the art department, like this one here, for the BuzzBox. And once it's approved and everything, I get it and I build it. So I'll just start from scratch, and I might scan in one of his drawings just for shape reference or size or various sort of things, and use it as a template. And I'll start building curves and surfaces and shapes in 3D and start building, in this case, a box. I sculpt it, put it together until we get the right shape and it's approved. Then I'll pass this model on to another piece of software where I'll add animation variables for controlling, in this case, flaps and other things on this model. And after that's approved, the model is basically finished, and I'll pass it on to whoever adds the shading and texture maps, which the art department has designed to be placed on this thing. And then we have a final sort of rendered version of this box, and it's approved, and then it goes on to layout and lighting.
My ship! Blast. This'll take weeks to repair.
The trick is to try to capture as much information as I can, get all the details, say, around the mouth, around the lips, around the eyes, all the expressive areas, without having so much detail in there that I get wrinkles. I want to keep the surface smooth, particularly on Buzz, who's supposed to have a very smooth face. So the idea is to try to make a balance between those, and also to make any surface features that, say, intersect the face intersect as smoothly and as naturally as possible. So I've got to balance several things.
Right? Isn't that so sick?
Each one of those white dots on his surface is one of those points that you saw me digitizing a moment ago. And from that, we've constructed all the surfaces. I can get rid of most of the other stuff, and we can see a rough approximation of what he'll look like when he's rendered in the film. After this, I'll add, all the color and all that other stuff to it. But this is pretty much all of the geometry, all the shape information that he'll have in him.
the software base we've been able to build up over the years that is oriented towards this kind of film, this kind of character kind of work. We could build a lot of power into the models that we build so that the animator could control it in a controllable way. Like if you look at the sculpture of Woody here, someone else did the sculpture based on some drawings that we had. And I got the sculpture in and I sort of analyzed it in terms of what I would need. I talked to John and the director and some of the animators and said, okay, well, what emotions does Woody have to have? And unfortunately for me, he had to have every emotion under the sun. Essentially, he's one of the stars. So it was like, okay, well, we got to do a lot of things here. And so I basically, drew the grid on him because I needed to digitize him. If you can catch the grid lines that I marked up on his face, those are points in space that define his face. And we have characters that are even more complicated than this. We tried to keep Woody fairly simple so that he was manageable, but the simplest form of controlling Woody is you deform those points. You move them around. But once you digitize it, you get a sort of fairly neutral pose. I've moved the eyes a little bit. And then I also did the body, built the body out of basic primitives that I could then work with. But carrying through with the face, then I would go in and I'd say, okay, what do I need in terms of facial muscles? First I'd add sort of the neck control, so I could do something, I could swing his head over like this and have him, turn his head side to side. But we built a system that allowed us to build in essentially facial muscles, to sort of represent muscles in a simple form. It's not the full complexity of the human body by any means, but still facial muscles that could allow him to lift the side of his mouth, to twinkle his nose, to puff his cheeks out. So I can get the basic shapes running, and then I could, then I'd add a control here to sort of change his jaw so he can open his mouth. And then I might add another control to make him smile. So you build a sort of software that allows that level. And even, you can think of that as being pretty primitive, in some sense, but that's the kind of thing that, 10 years ago, we really weren't thinking of building. It was more, you were just trying to get anything up on the screen, and we've come a long way, and the whole industry has come a long way in those 10 years, 10, 15 years.
Yeah. So that video, I found it while I was doing all the work for this this presentation today, like this lab, and I thought it was fascinating just how insanely new all this tech was for them, and it was all emerging. And something like the pen, where they tap on the different faces of the 3D sculpture, is unbelievable to me. I think that's the coolest thing. And what kind of scared me the most was just how bad of a frame rate the computers had. And I'm like, I could not just take my time. Yeah, right? Like when I have like 30 frames in my Blender file, I'm already mad. I'm like, this is unusable. But they had like 1 FPS. I'm like, that's crazy. Yeah, so that was a really cool video. I wanted to share it. So what today is about though is we're going to review on some lecture content. So when I was doing the review on section in Modeling 1, it was much more where I could just follow exactly the the lecture slides and everything. But this time around, it's going to kind of I'm kind of taking what Gavin wants me to present, which is most significant for this week, and he wanted me to do constraints and everything, and I feel like that also makes sense. But then afterwards, I plan to go through making the deformation rig for one of my models, and because you will have to do that for, I believe tonight's the due date, right? So I'm gonna kind of go through making my model and doing the deformation rigs on it, and yeah. So constraints, keeping your rigs in line. These are the way that you're able to communicate between the control bones and the deformation bones. And the way you do that is with constraints. But before we talk more about that, we're going to talk about anatomy, our own anatomy in our bodies. our bodies are full of constraints if you really think about it. And the main examples, of course, are the bones, the muscles, the joints, and the tendons. So the joints are the bones are obviously the rigid structure of the body. They kind of keep everything in place, the distance away from everything, the sort of the firm foundation that your body works on. And you can think of these as like the place that you start making everything else from. It's like the foundation, right? The muscles obviously move the bones, and they are a big part of your facial expressions. In fact, that's how your face is able to make all these expressions in the first place. You have joints, which are the rotation of bones, and have certain limits to them as well, which are very much like constraints. And then tendons are, in a way, a median between bones and muscles. It's the way that the bone or the muscles can connect to the bone and interact with them. And yeah, we'll go into each one. Bones, I like to think of them as the deformation bones in the body, where when you move them, the entire body moves as well. Like your entire skin weights and the meshes and everything all move together with the bones in your skeleton. The muscles are like the controls, where it kind of pulls the bone with it, right? And that's very evident in the face, where you have a lot of how many, I don't even know how many muscles are in the face. It's a lot of muscles, right? And so we try to replicate that or capture that with all of these deform or these bones here on the face, right? And then joints are, they act as physical constraints, right? They are bone pivot points. And so in our bodies, we have a few different types. Some of the main ones, the ball and socket joint, which is, primarily in the shoulders, and it's also in your thighs or your femur connecting to your hips. That's kind of it has a very wide range of motion, right? You can move your arm forwards, backwards, right? You can move it up and down, and you can also move it in this direction as well, right? So it's kind of a 3-point axis with some limit where you can't really turn it like all the way through your body, but that's probably the most complicated part of any rig is your shoulder, especially for the body. At least it's a pain, especially not just for the actual bones itself or the constraints, but also the weight paints, right? When you have like, the worst thing is when you make your mesh and you have like the arms like this or like this, and then when you weight it, and then all of that geometry just kind of lives with it.
That's why exclusively weight painting T-pose.
Yeah, you have to do the T-pose, right? Or else that happens. And then you have I believe it's the hinge joint, which is it's in your elbow, right? And so it's locked to a single axis, right? And so that's that's really easy to do for when you're making your constraints and everything, because you don't have to worry about any other axes. You don't have to worry about things like it was a gimbal lock, because there's only one axis to move on. So your model just won't get stuck and not move anymore when you're trying to rotate it. But with something like the ball and socket joint for your shoulder, you can't use the Euler rotations. You have to use the quaternion, or else when you rotate it, let's say forwards and then this way and then another direction, two of the axes are going to be lined up with Euler, and so you can't rotate on a certain axis, and it's really annoying. This all sounds kind of confusing and like, what are these quaternions, Eulers? But as we see the actual demonstrations in the future, we'll understand that better. And then lastly, we have your wrist, which I forget what I think it's a planar or joint. How's it going? And this one, it's locked to only two axes. right? So with my wrist, I can move it, left and right, up and down. But when I try to twist it, it's my arm that twists, not the joint itself, right? And so we would have to replicate these in our controls and constrain certain movements based on what each of our joints in our bodies requires. So if you are having a difficult time figuring out what kind of constraints you're going to be using for a certain part of your body, always just refer to your own body and move your arm or your finger, see what you can move, right? Because that's probably the best way you can uh, kind of figure that out without looking online. And then lastly is the tendons. Tendons, I kind of think of them as the mechanism bones, the MCH bones, because it's like the bridge between the controls, which I consider your muscles, and then the deform bones, which are your actual bones, right? They are just the connective tissue and everything, but they have the way that they are laid out in your body. There are certain limits to the size of them or the paths that they can go, right? And so in a way, they act as the mechanism bones. And so that's all like the human anatomy stuff. And what I wanted to do now for the building on section is I don't want to keep talking about things. It's not how I teach the best. I want us to explore some things. I want us to explore constraints for ourselves with our mouses and keyboards. So Blender constraints. These are fun. We don't know what they are yet. We're gonna learn what they are just right now. So there's gonna be this tab. I'm gonna show you it in Blender. When you're making bones, there's the bone constraints tab, and it's gonna have all of these different constraints you can use. And it's a bit overwhelming at first, but we're gonna go through half of them. We're gonna go through these ones today. And the reason is because the ones in the middle, these ones are what are most relevant for making rigs themselves, whereas the other ones on the sides are a little bit more procedural and aren't going to translate as easily into baked keyframes, I'm pretty sure, right? And these are just the ones that make the most sense when you're making rigs. So what we're going to do is I provided a blend file under week 2, and you're going to see that within that file, there's a fun little interactive way that we can see all these constraints in action. And I'll give you a second to download that if you want to participate. You don't have to, but this is a good way to have a point of reference and just have fun. And whenever you are enjoying or doing something, I find this is kind of how I learn. When I do something, I learn much better than being shown something. And when I get shown something, I'm just like, this is boring. I want to do something. I want to do something like tangible, right? So that's what we're gonna do. So if I go in my scene here, you will see that first thing I did was I color coded by default, so right now I'll set it to pose mode, but usually it's going to be in object mode when you're doing other things in your scene. And you'll notice I put this gray box here that says target bone. The target bone is, in this case, it's the one you interact with, right? And so I also could consider that a control bone, so CTRL, control. And so the constrained bones are the green ones, and so they react to the target bones. They are also known as the mechanical bones or mechanism bones, MCH. And the point of doing this versus we haven't even talked as much about deformation bones yet, but the deformation bones are going to just be the bones that connect to your meshes themselves, right? So they're skinned and everything. They have weight paints. And so the deformation bones, we ideally just want to set and then let them be, right? but then all of our actual rigging will happen between the mechanism bones and the control bones. And so having this separation just prevents any sort of problems later on. Because if you just go from the control bone and then you add your constraints to the deformation bones themselves, it's much harder to fix up certain deformation bones later if something comes up, right? So having those separations, those layering, that layering helps a lot with organization and just backtracking, right? And so constrained bones are the green ones. And so that means we're only going to really interact with the gray ones here, and the green ones will react to what we do. So starting off, we have copy location. Pretty simple to understand what that is. So so if I click G and I move my cursor, you see that that bone will just follow it exactly. But because it's only copy location, when I rotate it, it will not copy my rotation or scale, but it only copies the location. And you can see that underneath this green bone here, so we're in pose mode also, and you have to make sure that you're already highlighting the bone and then you go into pose mode. Right? There is these options here on the right side, right? And so you can get confused and accidentally add an object constraint. You see there is constraints and then there's bone constraints. So object constraints look similar, but they're not exactly the same, or they don't work at the same level as the bone constraints themselves. So make sure whenever you are making constraints, for your bones, you add them with the bone constraints. And you'll learn really quickly that, certain things won't happen if you do it with the constraints. But you'll see in here, we have the target, and then we have the bone of the sub-target. And so the target is always going to be the bone that this bone is referring to, right? So that could be, it doesn't have to be, well, in this case, it's a bone, but it could also be like a curved object, like a NURBS, some sort of shape that you use as a placeholder for a bone. Those are usually called widgets from what the book says. And the point of them is just to have a visual of what that part of your control is, right? Because if you just have a bunch of bones that you're moving instead of shapes like stars or cylinders or cubes or whatever, it can get confusing of which bones you can interact with and which bones you can't. And I'll show that in a little bit. But yeah, you can see here also that there is the head and tail option, which changes where so this is the head of the bone. It changes where the head of the bone is copying the location of this bone, right? So right now it's copying from the head right here. And I set it to local space. So that means it's on its own axes, right? But then if I set it to world space, it's going to just copy the actual bone itself in the entire world space, right? So that could be something you would want. Like what's cool about this is if I scale, it will move the bone, but it won't scale it as well, right? So that's a helpful thing to know, right? Because you can move it, you can rotate it. You see also it doesn't change the direction in this case, right? So there's a bunch of cool transform possibilities with constraints, right? So next is the copy rotation. This one is pretty straightforward as well. You can't scale it, you can't move it, but you can rotate it. And it copies exactly where your bone rotates. Right? And so the setup of this one, pretty straightforward. I set it also to local space. If I set it to world space, it should look pretty similar. Yeah, it should look similar. But yeah, these are a good way to, like, if you mess around with these options here, you can get different results. Yeah, that one's pretty straightforward. Copy scale as well. It changes the scale. Makes sense. But then you can't rotate or you can't move it. Right? So yeah, those three make the most sense. Next up is copy transform. This one is all three in one. So I can move this bone, I can rotate this bone, and I can scale it. Yes?
For the copy transform or the copy rotation, to make that offset, we were doing an edit mode.
So this offset is coming from, so if I turn off the influence, I can move this bone, right? So I set the bone's position when the influence is off. And when I set it, I think, yeah. So the bone constraint's not on. I set the bone's position, and then I added the bone constraint now, and I added copy transform. I set the target to this armature, which is the constraint showcase, which is all the bones you'll see here. That constraint showcase is just the entire armature, which has all the bones in it. And then now I can add the bone itself, which is this one. And so you see how it snapped straight to there. That's because by default, it sets it to world space. You'll see here, it's set to world space. So when I set it to local space, it will, it sets it, that's why. Because you set the position not in pose mode, in edit mode. Yeah. Yeah. So wherever you set in edit mode is the local space. You see? And so now it's there. And what's good about this versus traditional parenting, like it to the object, is if I rotate it, it's not going to rotate it with it, right? Like it's not all just gonna move in an arc, right? You know, like when I would rotate this bone, it would usually rotate this in an arc if it's a child object, right? However, in this case, because it's just copying it at the object level, like at the local level, it's not doing that. And so that's good for whatever use case you might find for that, right? So I do all this. There you go. So, any questions so far? Excellent. Okay. So, now it gets a little bit more fun, a little bit more interesting. We got the limit ones, the limit options. So, ideally, you'd probably use these in conjunction with the copy constraints as well. And so limit distance, you'll notice that I can move this bone, but then once I hit a certain threshold, it's going to follow my bone, you see? So in a way, this acts, you could think of this as a way you can do stretchy limbs, where at some point it starts to pull with you, but then close by it doesn't, right? You can see here that setup here, you can change it from head to tail. So now it's going out, it's following the tail instead, right? You can change the distance, so how far it takes to limit. You can do the opposite, where it's like it makes a bubble around the bone itself, so that the bone kind of is scared of this bone, and then it runs away. You see, it's very fun just to kind of mess around with all these parameters here on surface. And so now it's just gonna, I think it's just gonna stick to it now. Yeah, in this case now it's just sticking to the surface that I specified. Next is limit location. Oh, is that location? Yeah, it is. So limit location, unlike limit distance where it's the distance between the bones themselves, limit location clamps the location of that bone that you're moving to a certain axis that you of your choosing. So you'll see here that, as I said before, you would probably use these in conjunction with a copy location or copy whichever constraint as well. So what's happening is when I move this bone, it's copying the location, but then it's limiting its location to a certain axes only. So I set it to 0 on the x and z, but then on the y it can go from 0 meters to 1 meter, which means it can only go, in this case, up and down, and that's the only distance it can move, which is great for specific, like you can use your imagination on when you can use this for. And does anyone know why? Because we know that blender up is Z. Do we know why for this bone it's set to the y-axis for the maximum instead? Yes, exactly. So it's using the y. So bones will always have y facing up instead of z, which I think is interesting. You know, it's a weird. Usually, I'd expect it to be the same up for every single bone or for every single part of Blender, but yeah, I think it's because Blender is like past 3D applications, animation applications like Maya have Y up, and so that probably just translated from Maya because it's probably easier for animation to translate the same Y up on the bone. But yeah, that's why, because it's in local space. Bones will always have Y axes up and then X to the side, and then Z is kind of like the depth or forward and back. And then next is limit rotation. Simple. So you can't rotate or you can't move. You can't scale it, but you can rotate it. And you can see I specified that it only rotates in a 90-degree cone facing upwards. And you can see from the side angle, it doesn't rotate to the sides, forward and backwards, only to the sides. And it doesn't twist. You can see here this is what I set it to. You can refer to this always. And I set it to local space. If I set it to world space, that's when it changes its axes, because the y-axis is facing, it's like in the forward direction in Blender's case, and so this bone will just replicate that, right? Next is limit scale. So I can't move it, I can't rotate it, but I can scale it. And you can see the bone will scale up, and then if I go to the negatives, it will also scale back up because it's not changing its position, which I thought it would just do a negative. I guess I have to set it to negative. Yeah, I believe so. Maximum, minimum. But you can see here, it changes the scale. And I think the last simple, like the medium difficulty constraints to understand is the maintain volume. This one, it's scale based and it will maintain the same volume no matter what scale. This only affects scale. No matter what size it is, it will always keep the same volume, but it will attempt to change the size to fit it. So if I scale it down, right, it's gonna just kind of move out to the sides to keep that volume, which this is probably very good for squash and stretch, right? For like a bouncy ball. You don't have to worry about animating it down and then outwards. This will just, you see, very simple. It's all done in a bone, right? And so instead of having to animate this bone itself, all you have to do is you just have a control that you can scale. Yeah.
Could you have an entire armature set to maintain volume and have like one bone so it controls the squash and stretch at the time?
Like an entire body, yeah, you probably could do that, yeah. And what that would do is it would change the entire mesh itself. It would could like stretch it up, stretch it to the sides and everything. I think that would be cool to try out. You should totally. It should work, right? If you have a single bone as the skinned bone for that entire mesh, and then you do that. Yeah, I want to try it actually as well. So I'm gonna make in this case, I'm gonna make a cube. And I'm going to add some subdivisions. And then just move that up. If I add a new armature object, it's going to place that bone right in there. And I'm going to scale this down 0.5. So now this bone is the entire size of this cube here. So I'm going to call this the, let's say, constrained bone. Constrained bone, and then over here we have the target or control bone. So now if I go Control Tab Pose Mode, I select this bone here, add a bone constraint. I add the maintain volume. And I also believe I added if I check it, I added a copy scale to change the scale as well from the control bone itself. So first I'm gonna add a copy scale to this bone. So now it scales with it. And then I'm going to add a maintain volume. And so now this bone will do as it should, see? So now I'm just gonna select the cube first and then select the bone, Control P. Just make sure the mouse is there, Control P. Set parent to object with automatic weights. And so now the bone, if I click and I check the, I check the cube's vertex data, there's the constraint and the control bone. You don't have to worry about following along. I'm just testing this out. Now we're curious. So if I select the cube and then shift select armature and then I click, oh wait, no, opposite way. And then I weight paint, you can see the constrained bone has the full weight, which is red. And then the control bone over here has 0 because automatic weights means that the bones closest to this cube are added to the weight or are given weights. So if this all worked out, we should see that it works. That's pretty fun actually. You got it on a whole armature?
It's not like, I mean, I think I like messing sense, but
Oh, nice. That's great.
very cool.
It is fun. It's a good way to do like some fun squash and stretch and everything. I'm just gonna leave that in there. It's fun. All right. So now we are going to look at transformation. Transformation. I was confused. Like when I was looking at this, I was confused too because it seems like it'd be similar to copy transform, but it's different. It's kind of like a baby or baby driver, like the like drivers themselves, which we'll learn about next week, are a way to use like they're a way to control one part of a object's transform data with another object's transform data in a way that's not like a constraint. It's kind of its own thing that can be keyframed and everything. But this is kind of like a mini driver in a way, where what I'm doing is I am assigning. So first of all, I'm saying that I want the position that I move the map from, which is this bone. So wherever I move this bone, whether it's 1 meter up, 1 meter to the side, 1 meter down, will translate to the scale of the target bone, the green one, changing, right? So if I move this bone, it's going to change the scale of that bone. You see? And then if I change it, you see it to the sides. Right? So this is a way to translate the movement data or the rotation data or the scale data to the target bone's position, scale, rotation data. And this is also possible with drivers as well, though drivers are a bit more technical and have different use cases. But that one's pretty cool, I found. Next is clamp 2. This is only for curved objects. So if you have your control widget objects, like maybe this sphere, this disk, or a cube, or any sort of shape that you want as something that the animator will be able to move. This is a way to do it directly from the curve object to the bone itself, which I don't know how, like if this is a common way to do it. Like I'm not sure if this is reliable or anything, but you can see here that this object is just curves. You can see it will move, it will try to find its origin or its place to kind of reside. But the main thing is that this bone will just follow this curve here, right? And if I go to pose mode, you can see also that when you're in pose mode, you can't interact with that curve. And so that's an issue with this because you're supposed to be able to interact with the entire armature when you're animating without having to switch back to object mode. So this is a per object at a per object level, which might have its uses if, let's say, you have this as the base or the root of your entire armature, and then you want to move that armature at a per object level versus a per armature level. This is a way to do that, right? All right. And next up is damped track. So these are now the more complicated bones, but this one's pretty cool. This one tracks the bone, it tracks the target bone. And you can see in here that you can change the axes that tracks. So right now you see the axis pointing at it. And remember, once again, to turn on these axes, you have to go into your viewport display under data and then turn that on right here. You also change it to be in front and everything. This is where you change all the different options. You can also change the way the bones look. You can change it to stick bones if you want like a stick man armature looking thing. B bones, which is these are going to be bendy bones, which we'll learn about soon. Not today, but soon. And then we have envelope, which they look weird, so I kind of stay away from these ones. They kind of creep me out. I don't know exactly what reason they have, like what you use them for. And then wire, which is just very, very thin. And I'm sure you can make your own or kind of insert like your own kind of visuals for the bones as well. And yeah, now back to this. You can see that if I go back to the constraints here, the bone constraints, I can set it to also to the z-axis to track, and you see that the z will follow this bone. But I like to do y just because it makes the most sense. And you can also reverse the directions as well, right? And the thing about, so there's a few different tracks you can use in Blender. The damp track gives you pretty good results overall without having to tweak. There's also locked track and track 2. But damp track kind of has its own algorithm that it uses to find a very smooth kind of path to take. And you can see when I move it over here, it kind of rotates the bone 90 degrees along the tilt here. You see when I had it over here, X was facing upwards. When I rotate it, or when I move it over here, now it's Z. And over here, it's going to be negative X. See, X, negative X. And then, oops. Over here, it's going to be negative Z. And what that does is that is kind of how quaternion, like it's kind of leveraging quaternion in a way, where it doesn't have a gimbal lock, it doesn't snap. You see here, it smoothly transitions back to that positive z-axis. And no matter which way I turn this, it will never sort of pop, which I'm pretty sure you'll notice in one of the next few tracks, it's going to do that. Yeah, damp track is really good for smooth tracking. This is inverse kinematics. So IK is a way that you can take the child bone of, let's say, your hand, for example, and without having to move everything else in the chain, you can move the hand and the rest of your arm will follow that bone without you having to, let's say, with forward kinematics, where it's from, let's say, the elbow to the, or to the shoulder to the elbow to the wrist, you would have to move the shoulder first and then the arm and then the hand. In this case, you just move the hand and everything follows. And a lot of games do this just because, like, if you have, like, let's say a user-generated content for characters, avatars, you wouldn't want to use forward kinematics. You would use inverse kinematics, so you can just kind of plop, you just make the weight paints and you just plop whatever you made into this IK system, and it automatically does all the animation for you, all the rigging for you. And you can see if I move this, so if I click on this object here, I call this is the IK handle. I probably should have named this to control, because it's a control bone, so excuse my sloppy naming. Control IK handle, because this is controlling the rest of the IK system here, right? So if I move this, you will see let's say this is your hand, everything else will kind of bend with it. But then once I reach a certain threshold, in this case, it will just go fully straight and it won't follow. You could add like a stretch 2, for example. Let me see if that would work, actually. Let's see. So if I add that to here, oh, I should probably set it back to, there we go. So if I click on this bone here, the yellow bones will always be like the bones that have the IK actually on them. That's just the color that's been decided. You can change that though. But if I add a stretch 2 and then the target is this right here, oh, you see here we're getting a funny result actually. Not what I expected. Can I tweak it a little bit? Maintain volume. Yeah, so you can see that it gets very confusing when you have the more confusing constraints on. It can get hard to figure out what's going on. IK itself can be a little annoying to set up sometimes because you also need to make sure the pull vector, so this is the pull vector, and the pull vector is wherever this bend is facing. And so making sure, it's always important to make sure that you have the right axes aligned, or else, like, it's always the bone axes that matter so much when you're setting up something like IK. You see here, I can just rotate it. And then up here at the hand, this is like your hand. You can rotate this separately, right? And this is just copying the location of the tail end of this bone, right? So that's IK. This is a reference point. It's not very complicated. I kind of left out some things intentionally just because I don't want to give an insane IK rig, because you need to learn how to bring all these constraints together, right? So next is the spline IK. This is IK but with curves. So I'm not sure how often we're going to be using this one. It seems like a very specific use cases, maybe for something like, I'm imagining a tail or something for a character. And so what this is doing is when you make a curve object, let's say like a Bezier curve, you have like a point that's 0 and a point that's 1, and then it interpolates between all those points. And so what I did here was I added a curve, and then if I go into here, you see the final bone has a constraint, and it's a spline IK. And so it takes the point from 0 here, and then it sort of interpolates between all of those curves all those points on the curve. And it's a little hard to set up, I found, but you can refer to this now if you want to figure out how to do that in your own rig. And so you can just kind of have a very unique pattern, a very organic pattern with bones. And it's very easy to just move it all together versus having to move every single bone separately, right? And you can also, if I go back here to pose mode, you can change, I believe, fitting your divisions. I believe this would make it so that I can now stretch the bone. Or no. There's a way to kind of have the bone to stretch all the way to the end. Y scale, here it is. So there's the Y scale mode, which is, as we know, the Y of the bone is facing up along the bone. If we do fit curve, you'll see now that the bone's size, or all the bone scale will adjust to the size of the curves here, right? You see it gets very small, but then if I bring it out, it gets very wide. Just something I thought I could showcase, though I don't know. Yes?
If you were to say the maintain volume constraint as well, would it also make it like it would keep when you have say like a tail sweep,
Right.
would it help maintain the volume of the tail while it stretches? Because if you just stretch, you can just pull them.
If you stretch, yeah. Yeah, I wonder. Let me try that. Let's see. Let me just undo all this.
Oh, I mean, it might also be the XZ scale. So if you scale on both of those as well, it might just be the line of the bones.
Oops. Let's see.
I don't know. Breaks the scale.
I think what we can do though is, so we just leave it like this, and then so you want it to stretch, but then maintain the original scale.
Yeah, like the bones would scale relative rather than stretch.
Scale. Oh, like all of them scaled up.
It would
Oh,
become big as well.
there's an option here that says volume preservation.
Yeah, that's the same. Yeah, it would be the same thing as both the experiences.
So I think I had to turn on also the Y scaling. So if I go here and turn on fit curve, I don't know.
I mean, there's very many use cases for that. So, like for what I'm asking, so like it doesn't really matter if you figure it out or not. But
I kind of want to see. I'm gonna try one more thing. I'm gonna try. So
the actual
the actual maintain volume afterwards. So it is still stretching. Local space. Local space. No, yeah. I don't know. But it'd be cool to figure that out at some point. There we go. Just do like that for now. Yeah. So next up we got locked track. This one's like damp track, but it's locked under one axis only. And you'll see what I mean in a second here. I go back into pose mode, which also a little shortcut, Control Tab is how you can quickly enter from object mode into pose mode. And then if you just click Tab, you enter into edit mode. Right? And if you're in edit mode, when you click Control Tab, it just shows this option here. Right? So that's just a way to quickly change modes on the fly. Lock track, you can see here, it follows, but it stays under an axis that I specify. So if I lock it under the Z, you can see that it'll rotate around the Z axis. See? And so X and Y are free to move as well. When it's Y, the Y is following. Or, oops. When it's X, everything rotates around the X, see? When it's Y, Y kind of breaks. Because I think it's, yeah, Y doesn't seem to like it that much. Oh, there we go. You can see I can spin it in a circle, like I can just twist it. I'm not sure what kind of use we could find for this, but still cool. Maybe like some sort of lever or something. But then again, you probably just want to rotate it. And next is stretch 2. So this is the second last one. Stretch 2 is like damp track, so it still tracks the object, but it stretches to it as well. And it's locked on one axis. You see? So that's pretty cool. I can imagine this as something for like a stretchy limb or something. Though we probably are going to be using V-bones, not actual bones themselves, because something that happens, which is really annoying, when you transfer your meshes from Blender to something like Unity or Unreal, if you do this for the arm, for example, where you scale the bone to do the stretchiness of it, when you transfer it into those engines, it just scales the entire hierarchy altogether, and so your hand just becomes like super long, and all the fingers become like super stretched out. So you can't just stretch out the forearm, right? Unless you separate all of the hierarchy, and so that's what the bendy bones are for. It should fix that issue. But yeah, it's kind of annoying, right? But within Blender, you can do all that, and it's fun. And then last but not least is track 2. So track 2 is like damp track, but it forces a axis up always. It tries to keep it up as much as possible. So in this case, it's X. So when I rotate it around, you will see that it will, it will keep that X at the, like, facing upwards, right? No matter where. Whereas if I start to move it up and down, it's going to still try to keep the X as high as it can be. You'll notice that when I approach, that's not good, right? Yes.
So it's kind of like a camera tracking constraint, but for a bone. It's like with
Yeah.
the camera track too, it tries to keep it upright.
Yeah, exactly. It's actually, that's exactly
It's
it.
the same one.
That's well, that's beautiful, like a beautiful example, or like it works exactly the same as the camera, like, tracking. Yeah, it does the same thing where it tries to keep the one axis up always.
We don't want our camera going.
Exactly, or sideways. Like,
Yeah.
if you see, like, if I go back to damp track, you'll notice that this one's great, but if I were to start to rotate, you see that that axis turns 90 degrees. That would be nauseating for a camera. So this one just maintains X strictly upwards to a point where once you reach that 90-degree point, it's going to just snap it like a camera would.
But at that point, you'd probably add like range constraints to how you move the track.
Yes. If it's a camera though, which you might want to try to attach it to a rig, then this would work as like keeping the camera up as much as possible. But yeah, you would want to add a constraint to stop it from reaching that point, right? But yeah, that's all the bones that we are covering for today. You see, we covered, I go back here, we covered these ones. And the other ones, they're a bit more technical, a bit more procedural stuff. So it's probably not in our best interest to do that just for now. But you can see it also at the very end here, I put the curves I created. You can see, so these objects are not meshes, they are curves. And what I did was I increased the geometry's extrude size so you can see it as a physical mesh looking thing. It's not a mesh though, but it looks kind of like one, right? And so you can add materials and everything to it. And so these are ways that you can add visual indicators for your animators to animate your object. This is the very like surface level that the animators see, so they don't have to worry about seeing a bone, knowing what the bone does, animating the bone. And this star here is a fun way to kind of visualize certain parts of your rig. I like to use that for, in this case, it was for the IK for that, for this whole vector here, right? And so having these visuals is much better than having the bone itself. And so these are the ones I used, or I created. So that's the constraints we're going to go over, and no slides I'm going to show because that was, it was all doing versus showing. And so now what we're going to do is we're going to have time to work on our weekly activities if you want to do that now, or if you just want to hang out, that's cool. What I'm going to be doing is I'm going to be kind of creating a face deformation rig for this model right here. Does anyone know who this is? Actually, it says right there. But this is from my, yeah, go ahead.
That's Chrome.
Yeah, it's Crowan. You said it right too. You know, Logan in my group, he says it wrong. He says Crowan. And I'm like, that's not right. Yeah, put respect on his name. So Crowan is he is the champion of the arena in Stormhammer, and we unfortunately, just because of the way that we did our rig last year, we did not have to make a blender rig for him because our animator, all I did was create the deformation bones, and not even the face ones, just the body deformation bones, and I passed it to him. He made the blend shapes. He made the rigging. He did all the rigging, I believe, in Cascadeur, which is it's a good animating software from what I've heard. And so it has tools to kind of speed up the rigging process, but it's not very manual at all. So what I'm planning to do for this semester is, while you work on your weekly submissions, I can have the time to kind of do the same thing, to follow along and make, in this case today, I'm going to finish up the deformation bones for the face of Crowan. And I believe Gavin did provide the hippie drone face model for you to use. So that's the one I guess you'll be using. Or what I would recommend, if you have one already, is using this as an opportunity to rig one of your game models. It might take a little longer because it's a few weeks of time we're going to take on it. But if you want to do two birds with one stone, making the face rig for a character for your game, that's also cool too. Because that's what I'm doing. I'm using this as an opportunity to create the face rig for Crowan. In the case in the future I want to animate something with him, I'll have that as well. And so yeah, time is now yours. I will be working on this, and if you have any questions, just put your hand up, and I'll be more than welcome to help you with anything. And if anything comes up when I'm working on this and I want to mention it, I'll just, let you know. And yeah. Question.
About future tutorials.
Yes.
Will we eventually cover how to make, with like good looking like widgets and everything? Will we learn how to make like a nice control rig for animators? Like a good looking one that's
a good looking one
and usable.
I do have the ability to customize what these labs are, so I can totally slot in like how to make good looking controls.
Because if you look at like someone's rig and you see all the bones, whatever, and then if you download like one of the blender rigs,
yeah,
the control rig just looks so good.
There's so much readable. Yeah, I think that'd be a really fun lab to actually have. I think that's good.
Just making it look better, right? So.
Oh yeah. That's a good idea. I think I'll do that during one of the labs. Yes. So, I mean, I guess I can show you what I was doing uh, before. So this is Cron in my modeling or rigging scene. You see already the frame rate's a little tanked when I have the textures on. But you're probably going to have your model in a state like this, where there's no textures or anything, it's just the shading and everything. There we go. And so what I was doing was I was just like quickly drawing out using the annotate tool in Blender, just some face, so like what I would expect the face to kind of do in some areas. It's pretty rough, but I just wanted to quickly get something out. And the main thing is he's gonna be pretty angry, or like just really expressive in the eyebrows, his big eyebrows here, right? And his mouth also need with all these these teeth here. You want him to kind of have a very powerful face. You want it to be very impactful, very um, deformative, right? You want it to move. And so I'm just kind of saying, okay, so the cheeks, I want those cheeks to kind of really push up to his eyes, right? And I want the eyebrows to really move down. Maybe his nostrils to flare up a little bit, right? And the teeth to kind of go up, and everything just kind of move, scrunch together in the middle. And you'll see I just sort of drew a little bit of the bones around the eyes, which I believe Gavin showed you this in the lab or the class last week. And I was sent a example from Gavin. So this is what he did recently to for his face deformation rig. It's a lot of bones, I know, but it doesn't have to be perfect. You just need to. The main thing is you're trying to capture those loops around the eye and the eyebrow and above the cheek here, around the lips, the areas that need that movement the most are where you're going to put like the densest amount of bones, and then you'll see that we have these other bones. These are all for the deformations as well. So it's at the mesh level. These are going to be changing the mesh itself. And you can see that we're going to want to pull these bones towards these bones up here. So the point of having these up here is to kind of pull this eyebrow up as your muscles in your face too, right? If we go back to where was it? Right here. The facts that Gavin showed us, all these muscles here, right here in the, oops, let me draw. Where'd you? Oh my goodness. There we go. Turn this to. This is a large muscle, right? And so it connects from your eyebrow right here, and it pulls it, and it connects up here. All this is connected to your bone, right? And so those are where those bones are going to be, right? We're going to have them. In this case, it's going to be facing towards it. So you see also here, this is also a point of reference from Gavin. He sketched it out on the face first. This is what I did it was now 2 years ago in this class. And so it was this one was definitely much tamer than what it could be. This is also in Maya. So, that was a kind of a tedious thing I did to myself, was working in Maya, because I was stubborn and I was like, I'm not using Blender anymore. But I'm back in Blender because it's better for this, for just overall, it's much more straightforward. And you can see here that there's kind of a weird thing that happens with Maya where the bones, you can have like the transforms are much more confusing, is what I'm trying to say. And so the visual you get of a bone in Blender, like this octahedral shape, just makes a lot more sense to me than how it was working in Blender or in Maya, where you have sometimes you have like these single dots of transform data, right? And it's just a little more confusing in my opinion, but Blender just feels much nicer, right? You can see here if I bring this over, so we have those muscles here and we replicate that right here, right? And you see we have the top of the cheek and then we have these, if I go back here, we're kind of guiding our bones around these shapes that will have the most movement. So the center of your cheek won't really have any anything there necessarily. Yeah, go ahead. If you want to puff them, that's what this is here for, right? So this bone kind of crosses right through it. So if we pull that bone, it's going to just kind of move all these with it as well, right? And so just thinking about, okay, if I want puffy face, I'm going to have something at the very tip of that cheek to kind of bring it out, right? And let's say at the nose here, we have we kind of loop around the nose and then we add some at the tip, right? So there's no thing also, this is also what really got me so riled up when I was working on this in rigging like 2 years ago. There's no perfect way to do this stuff, right? At least for the deformation bones, like you're trying the best you can to capture those different areas of the face that you want to deform. The main thing is just capturing around the eyes. Those loops is I think one of the most important things, and also the mouth, right? But
how does it decide which direction you send the ball?
oh, deciding the direction.
Yeah.
That's something that just I always get worked up with. But what I find, let me go back to here. I was having literally a difficult time here trying to figure that out. Let me just turn off the constraints or the constraints. This. I decided to have, in this case, at the eye on the eyelids here, the Z facing up, because in my head I'm like, okay, in Blender Z is facing up, so if I also have Z facing up for my bones here, it would just make sense to me. Is that what you're asking? Kind of like which direction to have them facing along?
Aim the ball.
Yeah. I started it over here, so this is the beginning of the eye. I believe when I was making it in 2 years ago, I started the chain over on this side of the eye. I don't think it matters. I really don't I feel like there's diminishing returns. Also, you have to make sure you're in edit mode when you place them, right? But I started here and I worked my way down all the way here. And one thing you'll notice, so in this case, I have Crowan's eyes fully closed. And so it's very annoying or difficult to see where exactly these bones are because they're so huge, right? And what you can do to alleviate that is you can change, as I showed before, the display mode to stick, right? I like to use stick for the eyes. Also, by the way, if anyone wants to just go and get water, take a break, you're more than welcome to. And also, the class is I kind of wrapped up what I was going to talk about. So you're more than welcome to head out early if you want, but I'm just going to keep working on the rig here. And if you want to learn from what I'm doing here, then you're more than welcome to stay and ask questions. But yeah, I started here, and the way I place these bones is, so obviously you kind of click E to extrude outwards, but the way I get it to stick to the eyebrow itself is up here. There is the snap modes. I use face snap. And so face snap, if I hold down now, if I hold down control, and I confirm, that bone, that tip of that bone will stick to wherever on the mesh I was facing, or I was hovering over. I believe volume would go inside, yes. So the difference with volume is you can see here, instead of going on the surface, snap to volume will bring that bone between the mesh, wherever it is inside. Right? So I like to use, for this case, I'm just using face. But if I remove that, here we go. And so I just kind of follow this chain along, and I made sure Z is facing up. You can see on the eyebrow, actually, I didn't fix it yet. Z is still facing into the model, and it's better to be consistent throughout the entire model versus doing it the correct way many different ways, right? So it's better to be consistent overall. So I'm just going to consistently make sure that the Z axes are facing upwards. And the way I'm going to do that, before I do that, I'm going to just hide the hair for Kron. What I did for that was I actually, oops. So Kron's in a single mesh. I added a mask for the hair. You can see there's a threshold here. If I turn that off, you can see he just, yeah, he kind of has a, you know, he needs a lineup for sure. It's a bit rough these days. Because I also messed up the texturing. There's a bit of hair on the eyebrow. Because when I was texturing, I forgot to just hide the hair. You see, it's just, yeah, I know. Yeah. Also, speaking of which, your meshes, this is a good example of your meshes won't be perfect by any means, especially now. Like, this model isn't perfect either, and I'll show you. I actually touched it up since before, but the topology's not the best. The main reason is because the foundation of the topology was done with ZBrush auto retopology. So it's as good as you can get from that, which means the body itself has a massive amount of polygons that it doesn't need. It's fine though, because in our game's case, it was just one model. But you see here, 187,000 is not ideal. Not for a single mesh in most cases, but in our case, it was fine. Because, oh, is it 100? How much is this? Yeah, it's 187. Right? What was that? Clearly, yeah. Nightmare out there. But you can see that I added a bunch more loop cuts around the eyes and the mouth because it's so important to make sure you have that geometry for when your eyes opening and closing to displace properly, right? And so I'm not one to be able to tell you how to do effective manual retopology, but that's not what this course is about. You're given this face model to add the deformation bones to, so you don't have to worry about this. But in the future, the main reason it's important to have good topology is for this process of rigging, where you need all that extra geometry to make sure that your mesh deforms well without stretching and weird faceting, right? And also on the way back, I made sure to keep, so now the x-axis, because it's facing the opposite way, the x is facing outwards, but I kept the z facing up, right? And I know I'm jumping all over the place, but if I go back to the eyebrow here, if we want to change the rotation, like the pivot point of this bone, because you can see right now, Z is facing down. if I click N, the item tab here, this is your best friend when it comes to tweaking the bone without having to do it in the scene itself, and especially for roll. So there's this option roll. I'm gonna set that to 0. So right now X is facing upwards, which in my case, I want Z to be facing up, or as close as I can. So I'm just gonna set that to 90 in this case. It might be an arbitrary, like a random number for you. So you might wanna make sure you find a number that makes sense in your case. But I'm just gonna make sure these bones are all facing upwards. You could do this later, but I don't wanna have to go through, if I have 100, not like, maybe like 50 bones, and I have to do the fixing all of the orientations then, that would be such a headache. So I want to do it now. So I'm just getting that as close as I can. Oops. Change the roll. And if it's a bit of like a slant, I might want to make sure that this bone kind of just hugs the mesh as close as possible. That just makes the most sense to me. Right, just like this. Because when we will have this open, like this eyebrow go up, ideally we want that z-axis to kind of lead the way. So if I, let's say I go to the side view, I put my 3D cursor there and I change my rotation to 3D cursor. Ideally, that z-axis would follow accordingly, but since we're in edit mode, it won't. If I go to pose mode, it should. Yeah, you see? So I'm kind of just making sure that those z-axes line up with this rotation that we're ideally going to be doing in the future. Right? And now I'm just going to back into edit mode, rotate this. Always good to have references at hand. I can post some of these for you just to kind of look at shortly, especially the example from Gavin. I think that would be very helpful. Because I'm like, okay, what's next? I can see that in Gavin's case, he didn't add one straight down the center, I don't think. Oh, he did. There's a bone like going straight down to the center of the nose. One at the bottom of the eyebrow. Let's see here. This is I think it's the Rigify rig. I wouldn't say like follow it exactly, but it's a good way to see more ways people do it. And so I'm just going to follow this bone along, make sure I'm on active face. So where I'm imagining the top of that cheek bending to be, it's like right at the top of that bone. So probably like right here is what I'm predicting. So I'm dragging and I'm holding G to snap it to the surface with face snap on. Up to there. You can like feel your face and see what muscles are moving when you do certain actions, right? A bit of scrunch near the nose as well. So I'm gonna put that right here. And remember, Gavin said a minimum of at least 5 of these points just to get that arc, right? You can go more, you can go less, but the more you go, the more you have to worry about names and just the amount of ETH that you have to attach to the rig itself. Let's see. And so now I'm just going to follow what I was doing before. I'm going to make sure these Zs are facing up. There we go. This one's at a funny angle. And I'm just going to rename all these before I continue, just to avoid the pain of having to do that later. So in this case, the way I'm naming things is I'm doing L dot, so capital L dot. This is what I'm doing. You can have your own way of doing it as well. Def for deformation bone, underscore. In this case, it's going to be probably cheek, and then dot, whatever one it is. So this is going to be just cheek. And I'm using camel case for the actual name itself. And ideally, if it's something like top eyelid, I didn't put top itself, I put T eyelid, because if you have just too long of words, it can get confusing and a bit hard to read if it's too long. So just make sure if you have a long word, like left shoulder tweak, you could do like left shoulder LST or LT or something. I don't know. Just whatever makes sense for you. So this bone, where's this bone facing? That's the cheek. And yeah, when I have, let's say the Rigify rig, I believe this is Rigify. If you go armature, oh, yeah, so I don't have the add-on enabled on my laptop here. I have it on my computer at home. Oh, I should have my screen cap keys on. Sorry about that. Let me update that. I think it broke. There we go. And then rig. And my Rigify is off. Oh, it's built in. So you can go to add-ons and then type rigify or rig, and you see rigify comes up, I'm not saying use this to make your rig. Please don't, because that's not ideal. You want to learn how to do this yourself, but this is a great way to learn how how the Blender Rigify rig does it, right? And the names as well and everything. You see, in this case, the Z was facing up in this for the eyes here and for the cheek and everything. So I'm also kind of following suit in that way. As long as you stay on one axis consistently throughout an entire chain or group of chains, that's important. If you're like, okay, what's this bone called? Cheek. This is just simply called cheek. This one here, cheek TL001. I don't like having L at the end. I like it at the beginning. That's just preference though. There's no universal standard, which I mean, I like having a standard way of doing things, but it's kind of, the naming convention is yours to decide. As long as you use the main names like control and or CTRL, MCH, DEF, you should be fine. But the order is kind of all over from what I found. And all these bones are called eyebrow because I forgot to rename it before duplicating. So I'm just going to function F, or is it control function F2. And then I want to batch rename bones. I'm going to find everything that says eyebrow. This is why you name everything so well. And I'm going to rename eyebrow with cheek. And it says rename 3 bones. Yes. So it renamed all those right here. I'm just going to call this 001, 002, 003. That's the cheek. Take care. Then I want to bring this down to the nose. So you see we have a bit of movement here at the base of the nose. So I want to capture that with the bone. Actually, I might not want to keep it as a parent. I might want to just take this entire bone here and duplicate it. And remember, this is, if I go back, I can change this back to octahedral. So I want to stick, let's see, how do I want to do this? I don't want to do that. I think I might want to have the bone starting up here. No, I do trust this example. Right there. Boop, boop. And then I don't like how this bone right here, the head bone that I made, is kind of just in the way, because if I also put my bones to in front, I don't like it just being in the way there. So what I'm going to do is I'm going to make a bone collection. Call it head. Assign the head bone. And then now I can just, should be able to hide it. Oops, did I assign? Oh, no bone selected. Oh. Oh, I have to do that in, right, pose mode. Neck, and then head. Oh no. Let's see. There we go. Reveal selected. Right, so instead of hiding those, because that's harder to find, I'm gonna stick all these under, assign them to head, bone collection, and then now I can just, I should be able to hide it now. Take care. All right, so my head bone collection is still attached to the bones default collection, so I'm just gonna click on these bones here. 1, 2, 3, remove. Or I have to go in pose mode and then remove. Oh, there we go. So now I can just hide that. Edit mode. Also, whenever you, in edit mode for an armature, whenever you click A, it will always, oops, it will always add a bone because you can only place bones in an armature. And it'll add it to the collection that you have highlighted. So if I click A, Shift A, it'll add a bone within the bone collection. You see? And you see that, let me just show this. Whatever bone you have selected will show a dot to whatever collection it's attached to. Bone collections are actually, they're actually new, a newer feature in Blender. Like, not like new, but relatively. Like when I started, they didn't have these. They had a really weird thing before, a really weird option. Let me see if I can, let me see if I can, if I have an image of it. I don't think so, no. But bone collections are wonderful. Go. Remove bones. You see me touching my face often when I'm just trying to figure it out.
Well, I mean, it's the best way. You're your own specialist.
Exactly. You're your own best reference. Right? So I think, at least for now, I'm not going to really add bones at the bottom yet, because what's priority, I think, is the tip of the nose. So I'm just going to E, extrude, control, because that's where my nose moves the most. Even if it's subtle. So I'm gonna call this, let's say, def nose. What is this part of the nose called? Just call it nose for now. All right. I'm very big on making sure things are done right, so I'm always checking like, oh, what's this? What's this bone called? Nose L. Nose. Nose R. That's not helpful. Oops. So yeah, this will just be nose. L def nose. L def nose dot 001. And I do dot 001 because Blender does duplicates with the dot 001 by default. So that when I duplicate it, it just will follow it. Maybe I'll do 3 around the nose, because this guy is high definition. Look at this ugly seam. Look at this ugly texture seam. It's so ugly. Look at that texture seam. Shoot there. And then can snaps grid. Boom. Nice. I'll make sure this is on the right grid. There we go. And I'll put these in the same spot. Vertex is good. When you use vertex snapping you're going to do a lot. So I actually assigned, it doesn't work on this mouse for some reason. I assigned snap to my mouse itself, or the snap window. So if I do vertex snap, it will snap to the points of like the edges of the bones themselves. And also remember, you only need to do 1/2 of the face because we can just duplicate the side over unless you have a non-symmetrical face. Then that would be a painful rig to make. Nice, nice, nice. Where's this one? Eyebrow mid. Forehead. Goodbye. Attaboy. I said attaboy. You're gonna think about the different joints.
Yeah,
and everything now.
this is studying muscles.
Just studying for the practical.
Yeah.
There you go.
If you want surface deform rates for buys and back and buys today. So.
There you go. Do some squash and stretch. I guess I'll call it there. I'll see you all next week if you're here. Yes.